Excellent. Good morning. Thank you for joining us today. We're here to talk about security in the software supply chain. So I want to introduce myself. I'm Mary. I'm a director of security product and program management at Salesforce. And I primarily focus on security tools for developers. So this includes static code analysis, open source scanning, threat modeling, credential scanning, and security workflow for developers like that. I've been in software security for 11, 12 years. And before that, I was an application engineer focusing on optimizing codecs for different processor architectures. So thank you for joining this discussion about the security and legal impact of these open source components. Feel free to ask questions throughout. It's meant to be informative and helpful, so chime in whenever. All right, so who remembers this incident last year? It's just over a year ago. Yeah. Some hands go up, and it's interesting because this, you can imagine your name being up here with this malware being spread to 2.3 million users. And you have to ask that this attack not only attacked the software itself, but the whole premise of the company itself. It's not just your software, but the motto behind your company. So the interesting part is there was more recent research that indicated that this was going to be including future features like keylogger. So imagine like the depth of the attack if it hadn't been discovered at that point. And the sad or interesting or exciting news all up is that this is not going to be the end. So this article came out shortly thereafter. This spreadsheet and chart comes from the 2018 State of the Software Supply Chain Security Report from Sonatype. There are so many more attacks that have happened and will happen. And so the thing that's different here is before, if you had a zero-day attack, it specifically attacked like your particular piece of software and your customers. And then a phishing attack would also attack a particular person that used a particular service. This is not as careful. It is taking out entire swaths of companies by changing one particular open source component because they know that a lot of groups will have automated builds that pull down components. They'll just build it in, and all of a sudden it's deployed to millions or billions of machines. So let's level set about the software supply chain and how it's related and different than a traditional supply chain. So it's almost Christmas time, it's almost shopping time, and when you're pulling all of these components, you're bringing in millions of bits to build a particular toy or product. And if you're onboarding those different type of manufacturers if you're onboarding those suppliers to your manufacturing chain, you go through a supplier chain review, right? You go figure out how do they do access control, how do they build components, how do they make sure that the person walking in the door to work that day is actually who they say they are. We have to do the same level of reviews for the software components that we build into our software as well. It's not just, is your software secure, but all the components that you use should be secure. And then the more difficult part here is scale. We have hundreds of thousands of components that we build into our different components. For example, we have, if we just pick a number like 800 jars, all of those will map out to 9,000 transitive dependencies. And there's no human that can properly review all of those 9,000 components on a regular basis in time for you to make sure that the software you ship is secure. The other troubling part is that we have software as infrastructure, or infrastructure as software. So not only is the software in the components in your software at risk, but Apache, MongoDB, DNS, all the things that run your data centers are also susceptible to these same types of attacks. This is our Salesforce version of the software development lifecycle. And what happens here is that our team is chartered to integrate the security development lifecycle into the normal software development lifecycle. It has to be a partnership from the very beginning because this is not something that you can add on as a Band-Aid later. So I call this co-engineering all up. And you guys are here because you understand the importance of open source software. It is up to 80 or 90% of software. And so in general, if you make sure that the 10% code that you generate is correct or not vulnerable, you're still leaving yourself open to a huge surface. So I wanted to take a moment here and figure out who you are. Who's a developer in this room or related to development? Okay. And who are administrators or IT people? Okay, so it's a good mix, and some probably are doing both. So here I wanted to emphasize like infrastructure, this is the front line of security. This is where you have DNS, bind, MongoDB. This is all the stuff that's the basis of how people connect to our services. And then for developers, this is the core of the services that we build and sell to our customers, and the unknown security posture of all of these components affects both administrators and developers. So how does this affect you? Or the front line of security. That's, one of our key components of the security development lifecycle is that every engineer is responsible for security. It's not just a security team that says, hey, did you check this? Hey, did you design it this way? But you as an infrastructure person, as an IT person, as a developer, have to take into account the security and legal risks that you take when you incorporate these components. So let's figure out what's really inside. So when you talk about food, you sometimes wonder, like, is it organic? Is it grass-fed? Like, some people may want to be vegan. Like, you care about the quality and the ingredients of the food that you eat. Like, we're here in Vegas. There's a ton of awesome, amazing restaurants. You're probably going to seek some of those out. And when you're building your house, you often ask, well, if I'm going to replace this roof, should I get one with a 20-year warranty or a 50-year warranty? Like, these are all the types of questions that we ask when we build houses. And I'm a car person. I like knowing that I picked out my car because it's rear-wheel drive, mid-engine, 2 doors. Like, these are the things that I care about when I have a car to drive. And so I do care about what's in my car as well. And yet, many of the security reviews that I do, I find open source components that have never been updated since the day they were incorporated. So a lot of this, everything needs maintenance. The food that we eat, the houses that we live in, the cars that we drive, software should be considered the same. So the tricky part is looking at these attacks and seeing how they're different than other software attacks. So when you have infrastructure as code, this is something that will attack at a very low level. And it doesn't matter if your service is the most secure on the planet. If you can attack at a database level or a web server level, you can basically bypass all of your other attacks at a higher level. And when you have code and that you're integrating, these open source components, if you have a typo, if you have a person that takes over a GitHub account that's been deleted, like, these are things that other people can use to pose as attackers and potentially delete those components, the ones that you depend on, and then potentially even cause outages, right? So these are things that you have to be concerned about when you're relying on third-party components. And the worst case is what we talked about earlier with CCleaner. You're distributing malware to millions of customers and people. And that's a brand hit, that's a stock price hit, that's a very difficult price to pay when you're trying to be agile as possible. The tricky part with open source is also patching. Like, when people find different issues, you not only have to report it to an external party, you have to also make sure that they care about the security vulnerabilities, and because it's highly likely that they will not want to update it at all. And then the difficult part with upgrades as a second step is there are breaking API changes between minor versions and major versions. So if you update frequently, you have a smaller code difference to update and make sure that it keeps working. But if you have a major version, like I did a recent security review when they're upgrading from HBase 2 to 3, like, that wasn't something that they're willing to do in the short amount of time they had before release. So not only are you impacting functionality, but also security. And then last part is, there's so many different types of attacks. You have to make sure that the sources that you're upgrading from is actually also secure. So again, you can use hashes, figure out that the binaries that you're downloading are actually the versions that you expect to be installing. And of course, you have to balance all this out. one of the things that I learned from working at Salesforce is that they prioritize in this order: agility first, availability second, and security third. Frankly, I'm happy that security is in the top 3, but I also have to battle the fact that there are teams that will use whatever programming languages they have available to be able to get code and services out as quickly as possible. So this will introduce challenges when you're trying to integrate from if people are using Java versus JavaScript versus versus Go and Python, like all of these will introduce different challenges to your infrastructure. So what are we going to do about this? This is the painful part of what we used to do. So self-attestation. A lot of teams and companies do this. You have to request approval before you can use these different components. Each approval might take 4 to 6 weeks because some security engineer has to search on Google, NIST, MITRE, and look for these different components. And for the different ones, potentially do code review. And then for the ones that are higher risk, potentially even do static code analysis. All of this takes time. And then we have to hand off to legal. They personally, so they will initially wait for security to do these reviews first because they think that there's more likelihood that security will find issues before legal will. Legal has a pretty straightforward matrix of what licensors are acceptable, but it changes based on whether it's distributed or modified. And so those are the challenges that we have to face both from a security perspective and a legal perspective. So how are we going to make this better? So our mutual bright, shiny futures, we're going to talk about crawling, walking, and running, but first we're going to slither. And this is important because you may not even know the landscape of your software infrastructure and environment out there. So the key focus here is on awareness because you are trying to learn why people are using the different components they're using, how often they update, if they never update. And so you're trying to learn more about their capabilities and their release frequencies. And so it's important to ask them to consider the security and legal ramifications of the components that they're using before they start developing. The additional risk here for legal is that we have compliance requirements. They have to report this out. And if they don't know about a component, then we take on other risks as well. So the worst part here is about the workflow for open source ownership. So let's go through this. We talked a little bit about how we get patches and verifications out the door. And so you have to ask, does your open source component have an owner? It's like, if yes, great, let's update. If they don't have an owner, do you want to own it? Like, this is code that you have integrated into your environment to be agile. And yet, if they aren't willing to take the security ownership of these different requirements, then you have to ask yourself, do you want to take that on? Do you want to create a branch? Do you want to fork it and maintain those patches yourself? And if that's not something you're willing to do, then maybe you can take that open source component and replace it with something else. Or maybe you've decided that you no longer need that component, you can get rid of it. So these are all best case scenarios. At any point along the road, you can have a no that will require weeks, months of research to figure out if this is a risk that you're willing to take on. All right, so now we're in automation. Now we're crawling. So the way we started this was just looking at what is in source code repository. So because Nexus IQ Server has a command line interface, we were able to really quickly figure out how we can scan all of this with every single type of source code repository management system that we have. So this was really helpful because it didn't need any level integration. We can just sign up as developers in all of these different orgs and start downloading source code. Another great feature that was offered was the REST APIs. So here, we are able to use this functionality to pull the vulnerability data, the recommended versions to upgrade to, all of the useful information to convince developers this particular jQuery vulnerability can cause directory traversal, or remote code execution. It gave them the reason for why we were asking them to do this work. So this capability of bringing the information about vulnerability straight into our bug management systems using the REST APIs was really key in helping us close down these bugs and have 100% fixed rate. It totally surprised me, but I was amazed and happy, and so I'm going to give all the credit here. It's really helpful to put the bugs where the developers are already located. Having them log into a separate UI with a separate tool that they have to go into a separate data center to log into, it just isn't. It's every single click that you add is going to add is going to reduce the capability of developers being able to fix these things. So when we fall back to the software supply chain diagram that we saw earlier, we can see that at this point in this crawling phase, we're now covering the source code areas. And I put Hootie up on the codes to show that these are the different areas that we're going to be covering. All right, so now we're walking. One of the things that we were able to do with Nexus IQ Server is now integrate with build. And so we're challenging our build and integration systems to use this on a regular cadence so that they don't have to rely on people like the security teams to come scan. It's already there. Every time you have a build, you're downloading dependencies or you have dependencies in either your Nexus repository or Artifactory. You can integrate all of these different steps straight into existing workflows and not have to worry about covering all of these extra steps. You don't have to worry about people downloading new stuff because it's already going to be there. The other benefit here is that you don't have to worry about integrating with every single repository management system either. All of that you can integrate into your build and not have to worry about it. So at this point, we're walking, and we're covering more of our software supply chain. And now we have better coverage here. So this is where we can integrate security into the software development lifecycle. Instead of having them do extra steps, it's already exactly where they already are. All right. Now we're running. One of the things that we are able to do with Nexus Firewall is integrate with Nexus Repository. Repositories where everyone keeps all of their jars and dependencies. And so instead of having to have people fill out a manual report that says a request to say, hey, I'm going to be using this particular open source by this date and taking 4 to 6 weeks to do this, as soon as you put it into Nexus Repository, it will do security and legal scanning and give an immediate answer. So instead of saying, what form was that I needed to fill out? Who do I need to talk to? They don't have to worry about that. It's all integrated into existing tooling that they use. The other benefit is that we have consistent developer environments. And so most of our developers are using Eclipse or IntelliJ. And you can have plugins to be able to figure out, as soon as I refer to this library, it'll also do scanning at that point and figure out, should I be using this version or not? We don't have to ask. I've worked with teams where they are evaluating 3 different open source components, and they ask for this functionality up front. Like they're becoming more aware of the risks that they're taking, and they would rather use a library that is more secure than not. The other cool part here is integrating with Puppet and Yum. So we use a lot of this for our deployment to production. So because we can scan at this point, in case any other part fails, you have this last resort. I remember taking a kickboxing class at one point, and the instructor told us about a 200% solution. If someone's coming at you with a punch, you can choose to block or duck, or you can do both. And so by scanning and integrating at these 3 different parts, you really increase your coverage of the whole software supply chain. So now we have better coverage. We're looking at it from both the source code side, the build side, the deployment side. And from a security perspective, we're closely integrating to have this co-engineering partnership with developers directly. So when we were able to do our first scanning, something that used to take 15 minutes per those 800 jars ends up being something like 25 working days. And this is best case scenario. If you don't, and this time will easily increase if you add manual code review, static code analysis, and all these other steps that you can take. Scanning all of these takes such a short amount of time that it was well worth all of this effort. And so, you literally buy back time. And if you not only buy back time, think about all the extra people that you would have to hire and all the buildings you have to build. It just makes way more sense to use automation like this. The second part is comprehensive view of security risk. So this is something where not only are you integrating into build, you'll find that what people were self-attesting to is not quite the complete picture. When you integrate into build, you know exactly what binaries are pulling in, when they're doing this, how they're doing this, which ones, and so you have a much better idea of what your risks look like. Continuous scanning. So when you do manual code review, we only did review at intake. Again, similar to how when you take in open source components 8 years ago and you never looked at it again. Now you have continuous scanning that you can do on a regular basis, whether that's daily, weekly, per release, but at least now you know. And I've asked teams to basically build in a user story for every one of their releases to review their open source components, make sure they give themselves time to do this work so that they're not surprised when either security comes to them, I come to them, build comes to them and says, hey, guess what? You're building on insecure vulnerable libraries and that's gonna cause problems. So help them plan. Help them be aware of the risks that they're taking and then give them opportunities to plan for it so they can also properly staff up, schedule less time, or give them the opportunity to be able to do this in an easier way. The legal risk here is, single view of legal risk is also really important because at some point when you were only scanning or only reviewing at the parent or top level component, you didn't know about the 1,000 of other transitive dependencies that there were. So here you have a much better view of the actual legal risks that you're taking, potentially. So. It's supposed to be funny, but you can't scale, you can't expand, you can't increase your coverage, you can't reduce your time to market, you can't win customers. Like, you have to automate, right? And this is something, and I would say you also have to automate the right tool, with the right tool. Like, our company had tried different tools before, and because they were too noisy or too slow, this company had been trying to use different open source detection software for, I would say, at least 6 years. And so they're really pleased with the type of feedback that we can get in a really short period of time. One of my favorite quotes: no one knows everything. You just have to keep asking questions. Ask the 5 whys, like, why are you doing it this way? What components are you using it? When are you incorporating it? Just keep asking questions. So, and the point is to verify your whole supply chain, like from beginning to end, all the components that you use, all the different people that are being integrated into this process, whether it's 5 developers or 50 teams. The slithering phase, you want to start with just awareness at first. Like, you may not know the scope of the problem that you're facing, and so just, again, keep asking questions. You want to look at not only your software development lifecycle, but your infrastructure as well. There are attacks that are going to come in with open source components at every single level, and so for both developers and for IT administrators, like, this message is for both of you, and it requires partnership. So right now, I'm primarily on the software application layer side, but I'm working closely with our teams that are scanning at the endpoints. So we make sure that we see the right things and we notify the right teams. You can try it with manual and then see what the workflow looks like, but then go build it directly into the developer and administrator workflows so that everything can be easily automated. So I had a couple examples about food. You guys have been here all week. By the time you get home, you'll be traveling and eating airport food all day, and you open your fridge and you see what's in there. And even after a week, like, that lettuce is not going to be good, right? And for your house, like I have to go and make sure that my cat litter box is cleaned out. So like everything needs maintenance. In my car, I had to rush to make sure that I changed my oil and all this stuff. Like I like driving my car. It's got over 100,000 miles on it because I can't find another two-door rear-wheel drive mid-engine car to replace it with. And so I make sure it's in great shape. I change the tires, I replace the suspension. Treat your software the same way. Everything needs maintenance. Look at the components that you're using. Determine if it has a life cycle. And one of the other functionalities that Nexus IQ Server can do is just say, this thing's 6 months old, maybe someone should look at it. The greatest part is time savings here. So we were able to take 800 jars and look at it and say, okay, only 50 of them need to be upgraded. And then we were able to work with the research team at Sonatype to figure out, okay, of those 50, these 15 don't have upgrade paths. What can we do? Those 15 are the only ones that needed manual code review. That's a huge time savings compared to the 800 that you initially started with. So, are there any questions? Yeah.
Imagine a scenario where the teams get to decide what security they're going to do, what tools they're going to use to do it with. It seems like maybe you started there, and now you're at a place where everybody is using the same stack and that security level. Can you describe that process, or did the CIO come in and say everybody has to do this?
So the question was, if you have different teams that have different technology stacks, how do you incorporate with a single tool?
Yeah, and how do you get them to decide that's important to be the same as somebody else, absent the CIO
Right.
mandating?
There are many different places you could integrate. You could incorporate at the source code level, the IDE level, the build level. I've been working with teams to try to find the right integration point for them. So while they don't have to be doing the integration at the same place, Nexus IQ Server is flexible enough to offer multiple integration points so it can work with 4 different technology stacks. That's why I mentioned Artifactory as well, because half our companies using Artifactory, half. And so it's better to integrate with build at that point so that includes all the artifacts from Artifactory. So. So this, I initially presented this at Dreamforce a couple weeks back, where we did talk about the App Exchange. Those questions, I was referring to the Salesforce booth that isn't here this week. Come by afterwards and we'll talk about what we have plans for ideas for the App Exchange. It is really important because they're probably using just as many open source components as everyone else. So, you had a question?
Question on mindset, right? So how did the mindset change from you as an application security person or from the application security team? And how did the mindsets need to change in development to enable this to happen?
The mindset question is really important because when we first started using this tool, we would drop like one-off bugs. And at some point, someone said, you know what? I don't want to deal with this. I'm just going to take a mass exception, right? The reason why I really focused on building partnerships, working with teams to plan with their release cycle is that they can put in people and workflows to be able to better address these things. And at this point, this project has been so impactful that they said it was the best project to come out of security. So by working with release teams, by working with security teams, by working with development teams, you can say, I will give you as much time as you need. So I opened all of these bugs on the last day of the previous release. That way they don't have like one day, they have the full release plus all of the design time. So they literally had 3 or 4 months to get all of this done. And that's how we got to like 100% fixed rate. So it needs partnership, and by building that partnership, you create that mindset where everyone is concerned and wanting to fix these things. Thank you so much. Please.